Let's say the coordinates of point A are x1, y1, coordinates of point B are x2, y2. Well, here, uh, what is the average rate of change in y with respect to x between A and B? Between A and B, between A and B, that points A and B, average rate of change in y with respect to x is, delta y by delta x, or y2 minus y1 by x2 minus x1. You know this, right? Huh? Now, if I draw a straight line from A to B, if I draw a straight line from A to B, on this straight line also, the change is from A to B. Okay. So average rate of change on this straight line is also same. It's like you go from A to B. A to B, the distance is 10 kilometers. You take 2 hours to go. Okay. Somebody else also travels from A to B, 10 kilometers. He also travels in 2 hours. But you go with uniform speed of 5 kilometers per hour. But somebody else, this second person is, first he travels slowly and then increases his speed. Both of them have same average speed, right? You understand what I'm saying? Okay. For this fellow, for you, 10 kilometers takes 2 hours. For this fellow also 10 kilometers takes 2 hours. But first he goes slow and then increases his speed. What is his average speed? 5 kilometers per hour only. What is your average speed? 5 kilometers per hour only. So what I'm trying to say is, in both these lines, if you draw a straight line from A to B, the rate of change between A and B is for the straight line also same. Right? You understand this? This average rate of change in y with respect to x is called slope of the graph. Look at the curve that we have drawn. Have you heard of the term slope before? Slope. No? Say yes or no, please. No. Okay. At least in English. If not in mathematics. You know the meaning of slope of a hill, right? Do you know the meaning of a slope of hill? It's also called gradient. Here, this is delta y by delta x in the case of graph is also called average slope between points A and B, or it is also called average gradient between points A and B. You can call it slope or gradient. What is this line, straight line called? A straight line that intersects the given curve at 2 points has a name. A straight line that intersects the curve at 2 points. You have heard of it. It's called secant line. Have you heard of it? No? No? You haven't studied 10th class. You jumped directly from 7th to inter. So this line, straight line AB, is called secant line. Any line that's any straight line that intersects the curve at 2 points is called secant line. So in this case, the secant line is AB. This is about average slope. Okay. This is about delta y by delta x. Note down this, I'll tell you what dy by dx means on a graph. Before you note down this, the story is not complete yet. Listen to me. This point is A. What is its x coordinate? X1. What is its y coordinate? Y1. Look, what is this x coordinate here? X2. Y coordinate? Y2. All right. Listen to me. Let's say if a vertical line is drawn from B and a horizontal line is drawn from A, low. Let's say they intersect at point C. Now, what is the length AC equal to? X2 minus X1. And what is the length BC equal to? You understand this length is X2 and this length is X1. So this distance should be X2 minus X1. And it is Y coordinate means this is the length, right? Y2. This length is Y1. So what is this equal to? Y2 minus Y1. Now let's say the secant line that we have drawn. What is that secant line? AB. The secant line that we have drawn makes an angle theta with horizontal. Let's say this angle is theta. Angle made by secant line with x-axis is theta. Right? Now, can you see the right angled triangle ACB here? Huh? What is the opposite side of theta? BC. And what is its length equal to? Y2 minus Y1. What is the adjacent side of angle theta? AC. What is its length equal to? X2 minus X1. So Y2 minus Y1 by X2 minus X1 or delta Y by delta X. Delta Y is the opposite side of theta and delta X is the opposite side, adjacent side of theta. So you know the ratio of opposite side to adjacent side called what? Trigonometric ratio. Tell me please, ratio of opposite side to adjacent side. Tan theta. So delta Y by delta X is equal to tan theta. So tan theta is the average slope of the given curve between 2 points A and B. And what is theta? What is theta? Theta is angle made by the secant line with x-axis. Note down this please. Done? Now let's try to understand what dy by dx indicates on a graph. I'll draw the graph again. This is the graph that we were discussing between points A and B. So dy by dx is what? The rate of change in y with respect to x at one particular value of x. So let us take one particular point somewhere here. Let's call it P. Let's say its coordinates are x, y. Its coordinates are x and y. Okay. Now to find rate of change in y with respect to x, what do we do? At a given value of x, we construct a small interval around the given value of x. Right? In that small interval, as the small interval becomes smaller and smaller, as the small interval becomes infinitesimally small, okay, then the rate of change in y with respect to x is represented by dy by dx. Are you following me? Okay, that's what we have been discussing. So let's choose one more point close to P. There is only very small difference between their coordinates. If x coordinate of P is x, x coordinate of Q is x plus dx. And similarly, if y coordinate of P is y, y coordinate of Q is y plus dy. There is only a small difference between their x and y coordinates. The point Q is very close to P because we wanted to make the interval infinitesimally small. Okay, so choose 2 points that are very close to each other. Now draw a line, straight line passing through the 2 points P and Q. What is that line called? What is this straight line called? Secant line. Yes. So draw a secant line here passing through points P and Q. Okay. Now look at this horizontal line that I am drawing here. This horizontal line is of how much length? Dx. Can I say that? So if I say this coordinate, this point is C, PC is equal to dx, and QC is equal to, what is QC equal to? Dy. Right? So as the difference becomes very small, the points P and Q are very close to each other, isn't it? Okay. So when Q comes closer to point P, the secant line, can I say, as the point Q approaches P, can I say the secant line will become tangent line? You know the tangent, right? What do we mean by tangent? Tangent means, yes, please. It's not necessarily a circle, it is any curve. A line touching a given curve at any one point. Okay. So as the point Q comes closer to P, this straight line will become tangent, almost to become a tangent. You understand what I'm saying? Okay. So this was the curve that we have drawn. Look, these are the points A and B. Bring A and B closer to each other. When these 2 points come here, this is the new secant line. When these 2 points, when the interval becomes smaller, this is the new secant line. If the interval becomes even smaller, secant line will approach to become what? Tangent line. You understand what I'm saying? Okay. So as the interval becomes smaller and smaller, as dx becomes infinitesimally small, the point Q approaches point P, and the secant line will tend to become what? Tangent line. You understand this? So the tendency of secant line, as these 2 points come closer to each other, as the interval becomes smaller and smaller, what happens? Secant line will have a tendency to become tangent line. Do you understand this? Huh? Okay. So now look at the right angled triangle there. Where is the right angled triangle? Can you see the triangle PQC there? PCQ. Look at the triangle PCQ. Zoom in the graph and look at the right angled triangle. This is PQC. So PQ, the curve or the straight line. Curve is also a straight line between P and Q. When you zoom in, when you draw a line, when you draw a curve on a computer and zoom it in, you would see that it's a what combination of straight lines, right? When you look at this small part, when you magnify this small part, you will see that it is a straight line. So this is almost a straight line, PQ. So what is this equal to? Dx. And what is this equal to? Dy. Do you understand that PC is equal to dx? Do you understand that QC is equal to dy? Do you understand that this is a tangent line? Right? And this tangent here makes, let us say, an angle theta. This tangent with x-axis, the secant line has a tendency to become tangent line, and this tangent line makes an angle theta with x-axis. Right? So if this angle is theta, here also the angle is theta, and look at the figure. Look at the right angled triangle. Opposite side to adjacent side ratio is equal to what? Tan theta. You understand this? Okay. So this is slope or gradient or the rate of change in y with respect to x at one particular point in the graph. Okay. So this is slope or gradient or rate of change in y with respect to x at a given point or for a given value of x, at a given value of x, at one particular value of x, at one particular point in the graph. And what is theta? What is theta? Angle made by the tangent with what? With x-axis or with any horizontal line. So here theta is angle made by the tangent with x-axis. Right? Note down this, please. All right, let's try to understand how y behaves in different graphs and what this slope means in different graphs. Let's look at different shapes of the graphs, and let's try to understand the story that each graph is telling us. Look at this graph. This is a straight line. Now tell me, what is the story that this graph tells you? This straight line, let's say, makes an angle theta here. So this graph tells us that y increases as x increases. Is it? Is y increasing? Is y increasing here with x or decreasing? Increasing. How do you know when x changes from x1 to x2? Y changes from y1 to y2. You can see x increases, y also increases. What about the slope of the graph? What about the rate of change in y with respect to x? When I say slope, what it means is rate of change in y with respect to x. So what is happening to the rate of change in y with respect to x? Is y increasing at a uniform rate or at a non-uniform rate? Tell me. Is y increasing at uniform rate or non-uniform rate? Uniform rate. What do we mean by it? Uniform rate means, look, take any interval of x. Suppose, let's give some value to theta. If theta is equal to 45 degrees. If theta is equal to 45 degrees, Take any interval between A and B. What is the slope that you are going to get? This is 45 degrees, means opposite side and adjacent side are equal. It means y2 minus y1 and x2 minus x1 are equal. It means the slope is what? Tan theta or tan 45 degrees. How much is this? 1. What does it mean? It means for every unit change in x, y changes by how many units? 1 unit. Okay. y2 minus y1 is always equal to x2 minus x1. dy is always equal to dx. Even if you take a small interval. Because this angle is 45 degrees, right? Okay. When x changes by 1 unit in this interval, y changes by 1 unit. When x changes by 1 unit in this interval, y changes by 1 unit. When x changes by 1 unit in this interval, y changes by 1 unit. So for every unit change in x, y changes by 1 unit. So is the rate of change constant or variable? Rate of change is constant. You understand what I'm saying? Suppose if theta is equal to 60 degrees. Theta is equal to 60 degrees. What do you get? Tan theta is equal to tan 60 degrees. How much is this? Root 3. It means for every unit change in x, y changes by root 3 units. Are you following what I'm saying? Y increases. We are getting positive here. Change in x is positive. When change in x is positive, change in y is also positive. So when delta x is positive, delta y is also positive. So here tan theta is equal to dy by dx, or delta y by delta x is positive constant. Do you understand this? What it means is y changes, y increases as x increases at a uniform rate. Y increases as x increases at constant rate or uniform rate. Okay, it's like a body traveling with a constant speed. If a body travels with a constant speed, and if you draw the graph between distance and time, you would say that the graph is a straight line. In every 1 second, the body covers same distance. Okay, if your body travels with 2 meters per second, after 1 second, distance is 2 meters. After 2 seconds, the distance is 4 meters. After 3 seconds, the distance is 6 meters. So in the first 1 second, it has traveled 2 meters. In the next 1 second, it has traveled 2 meters. In the third 1 second, it has traveled 2 meters. You understand this? So it's a uniform speed. Similarly here, y changes at a uniform rate. Y increases at a uniform rate with increase in x. Let me draw one more graph. Tell me the story that this graph tells you. This is also a straight line graph. Tell me, how is the second graph different from the first graph? Slope is negative constant. Very good. So what do we mean by it? What do we mean by slope is negative? As x increases, y decreases. Look, when x is equal to 0, y has the maximum value. When x becomes equal to x1, let's say y becomes equal to y1, y has decreased when x has increased. So with increase in x, y decreases. Okay. So the slope is negative. Look at this theta. Is theta greater than 90 degrees or less than 90 degrees? Greater than 90 degrees. Greater than 180 degrees or less than 180 degrees? Less than 180 degrees, which means which quadrant? Second quadrant. In second quadrant, tan theta is positive or negative? In second quadrant, tan theta is positive or negative? Negative. So slope is negative. Okay, while measuring theta, you should always measure angle theta with positive x-axis. Don't say this is theta, this is angle theta. So angle made by the graph with positive x-axis. Here tan theta is negative. Dy by dx is negative constant. It means with increase in x, y decreases at a constant rate, at a uniform rate. You understand what I'm saying? With increase in x, y decreases at uniform rate. Okay, note down this. For example, if theta is equal to say 135 degrees, if theta is equal to 135 degrees, what is tan theta equal to? Quickly, tell me. If theta is equal to 135 degrees, is it positive or negative? Negative. So it is -1. Tan theta is equal to -1. Theta is equal to 135 degrees means 180 degrees minus 45 degrees. Tan 180 degrees minus 45 degrees. In the second quadrant, tan is positive. Even multiple of 90, you will get tan. So minus tan 45 degrees minus 1. It means for every unit increase in x, y decreases by 1 unit. You understand what I'm saying? If this angle is 135 degrees, what it means is that if x increases by 1 unit, y decreases by 1 unit. Is this understood? Note down this, please. One more. Look at this graph. Tell me what is happening here. With increase in x, y increases or decreases? Increases. But how is it different from the first graph? This doesn't increase at a uniform rate. Y increases as x increases. Look at the slope at different points. I'll take point A. Draw a tangent at A. Draw a tangent at A. Look at the angle made by the tangent with x-axis. Take one more point. Any point. I'll take point B. Look at the tangent drawn at B. If you draw a tangent at B, let's say it makes an angle theta. Theta 2. Take one more point C. Are these angles the same? Are theta 1 and theta 2 and theta 3, are they equal? They are not equal. If thetas are not equal, tan thetas at different points are also not equal. It means dy by dx at A is different from dy by dx at B, which is different from dy by dx at C. It means rate of change in y with respect to x around A or at A is different from rate of change at B is different from rate of change at C. Or I can say slope at A, slope at B, slope at C are different. You understand what I'm saying? Where is it small? Smallest slope is in these 3 points where? At A. At A, smallest slope. Okay, what does it mean? Smallest slope at A means y is increasing as x is increasing at all these 3 points. But y is increasing at a slower rate here. You understand what I'm saying? As you go to point B, the pace at which y increases, the rate at which y increases is greater at B, point B. You understand what I'm saying? At C, it's even more high. Okay, y increases at the fastest rate among these A, B, and C. So as go towards the higher values of x, the graph becomes steeper and steeper. It means the slope increases. It means the rate of change in y increases. So if I say y increases as x increases, at what rate it is increasing? Is the y increases as x increases, but at a constant rate. Is y increasing at a constant rate as x increasing? No. Is y increasing at uniform rate? No. Y is increasing at an increasing rate or decreasing rate? Increasing rate. You understand what I'm saying? So y increases as x increases at increasing rate. What do we mean by this? You can see, take any 3 points here at points A, B, and C. If you observe, at points A, B, and C, you can see that theta 3 is greater than theta 2, which is greater than theta 1. It means tan theta 3 is greater than tan theta 2, which is greater than tan theta 1. Do you understand this? It means dy by dx at C. It means dy by dx where at C is greater than dy by dx at B, which is greater than dy by dx at A. So rate of change in y is greater at C than which is that is at B. Okay, than that is at A. So the rate is increasing. Y is increasing. The rate of increase in y is also increasing. You understand what I'm saying? Whereas in the first graph that we have drawn, y increases, but rate of increase in y is a constant. Straight line graph. Here, y increases, rate of change in y also increases. Y increases, dy by dx also increases. So y increases and slope or dy by dx also increases. You understand this? This is the story that this graph is telling us. Note down this. Slope is generally denoted by m, so you can say m3 is greater than m2, which is greater than m1. M means slope. Yes, please. What's happening here? Tell me. In the fourth graph, is dy by dx positive or negative? Positive. Very good. It means y increases as x increases or decreases? Increases. Very good. Y increases at a uniform rate? Y increases at a uniform rate? No. Very good. Now tell me, how do you describe it then? Imagine you are climbing up a hill. Let's say this is a hill. You are climbing up a hill. Initially, the gradient is small. The slope is small. It's easy to climb. The hill becomes steeper and steeper at higher values. Isn't it? So the difficulty in climbing up, is the difficulty increasing or decreasing here? Difficulty is increasing because it becomes steeper and steeper. Okay. Here, in this case, initially climbing up the hill is more difficult. But after a point, it becomes easier and easier. Because the slope is small here. Okay. Slope in the literal sense I am talking about. Here the slope is high. So here you have a tendency to slip down when you are climbing up. Are you following me? Or else you can also look at it like this. Suppose if you take O and A, equal intervals of x. Take equal intervals of x. It's not equal changes in y. Look at the change in y. Look at the change in y. Look at the change in y. Okay. So for equal intervals of x, look at changes in y. So in the first interval, the change in y is high. In the second interval, the change in y has increased. But it has increased slowly. Can I say that when compared to the first interval? In the first interval, if change in y is 10, in the second interval, change in y is 8. In the third interval, change in y is 6, let's say. For equal intervals of x, in all these three intervals, y is increasing. Right? But y is increasing at a decreasing rate. You understand what I'm saying? Here y increases. In this interval also y increases. Here also y increases. But y increases at a faster rate here. So the rate becomes slower. Y increases, but it has become, the rate of increase has become slower, smaller. Here, if you go to this interval, rate of increase has even more less, decreased further. If you go to this place, for same change in x, okay, look at the change in y. Change in y is increasing. Between O and A, y is increasing. Between A and B, y is increasing. Between B and C, y is increasing. Between C and D also, y is increasing. But in this interval, y is increasing at a faster rate. Okay, here the rate has slowed down. Okay, rate has slowed down even further, rate of increase. Are you following what I'm saying? It's like decreasing, you are traveling with a decreasing speed. Okay, in the first 1 hour, you traveled with speed, let's say on an average 20 km per hour. So in the first 1 hour, you covered 20 meters. In the second 1 hour, you traveled 10 kilometers. So say in the second 1 hour, your speed is 10 km per hour. In the third 1 hour, you traveled with only 5 kilometers. So your speed is 5 km per hour. So what is happening to your speed? Decreasing, but you are still going forward, right? Your distance is still increasing. But initially, distance has increased at a faster rate. But as you go farther and farther, the rate of increase in the distance has slowed down. The speed has become smaller. You understand what I'm saying? So what's the conclusion here? Y increases as x increases at a decreasing rate. This is increasing rate. Here, Y increases as X increases at decreasing rate. So Y is increasing. What is decreasing? Rate of change in Y is decreasing. So Y is increasing, but dy by dx is decreasing. You understand what I'm saying? So here, or look at the tangents. Draw the tangents to the curve. If you draw the tangents to the curve at different points, draw a tangent at A. Look at the angle made by the tangent with x-axis. Draw tangent at B. Look at the angle made by the tangent with x-axis. Draw tangent at C. When you draw tangent at C, look at angle made by the tangent at C. As you can see, theta 1 is greater than theta 2, which is greater than theta 3. So tan theta 1 is greater than tan theta 2 is greater than tan theta 3. It means slope m1 is greater than m2, which is greater than m3. Slope decreases. M means here slope. Okay. So here, as you can see, tan theta decreases means dy by dx also decreases. So y increases as x increases at but at a decreasing rate. So in other words, y increases with x, but dy by dx decreases with x. Okay, note down this. Tell me if you don't understand anything. Now, you tell me the story of these graphs. As x increases, y decreases. So you're saying dy by dx is positive or negative? Negative. Okay. So y decreases at a constant rate, at a decreasing rate, or increasing rate? Huh? Suppose you are rolling down the hill. Imagine this is a hill. You started sliding it down. You started sliding it down. So you slide more height down in the first half or in the second half? Huh? So you decrease your height more in the first half or second half? X, divide x into two equal intervals. X to x. So the decrease in height is more in the first half or second half? First half. So rate of decrease in y is more in the first half or second half? First half. Rate at which you are rolling down or sliding down is more in the initial stage. Are you following me? Are you following me? Say yes or no. So the rate at which you are, decreasing your height is more at initial stage. So this is y decreasing at a decreasing rate. You understand this? Initial rate of decrease is more. Initial rate of decrease is more. Are you following what I'm saying? Here, if you look at 3 points, if you don't understand, take any 3 points of your choice and draw the tangents. Draw the tangents. This angle is theta 1, this angle is theta 2, this angle is theta 3. At A, your rate of decrease is more. dy by dx is negative. Of course, dy by dx everywhere is negative. Okay. If it is at A, if it is minus 10, at B it is minus 5, at C it is minus 2, let's say. So the magnitude of rate of change is greater where? At A. Next at B, next at C. So I would say modulus of dy by dx at A is greater than modulus of dy by dx at B is greater than modulus of dy by dx at C. Why am I writing modulus here? Number. If the number is minus 10 here, for 1 unit change in x, if y decreases by 10 units at A, for 1 unit change in x at B, if y decreases by 5 units, at C, for your 1 unit change in x, y decreases by 2 units. Okay, this is minus 10, this is minus 5, this is minus 2. Are you following me? Are you following me? So the rate of decrease is greater where? At A. The rate of decrease is next greater at B, least at C. You understand this? So here, Y decreases as X increases at a decreasing rate. Y decreases as X increases at a decreasing rate. That's the story. Similarly, you can find out yourself what's happening in the case of sixth graph. All right, I'll stop here for today. You must have practiced the questions that I gave you yesterday. If you have any doubts, you can ask me. Okay.